All right, Math Studies students. Now we're going to work on Chapter 20C, the derivative function. Some of you thought, oh my gosh, 20B was so hard, right? In assignment 20B.2, we found the slope. English people called it the gradient, and at a particular point. Okay, so when a single point touches a curve, this is called a tangent. We're going to be using this word. So a tangent is a point where the line, is a line where it touches a curve at a single point. Okay? So the slope at a tangent point of a curve is called the derivative function. It's got a very special name called the derivative. Okay? And so my original function is y equals, in our example before, was y equals x squared, right? So the derivative is often written like this, dy dx. You're going to see this for the rest of the chapter, and sometimes it's written like this with a f prime. Okay, so if you see f prime like this, or dy dx, that means we're finding the derivative. Now, let's look at the example that we did before. Okay, so in this example here, here we've got the equation y equals x squared. Now, what would at the tangent at x equals -3, what is the slope? If I look here, it goes down 1, 2, 3, 4, 5, 6, and over 1, right? So this slope is down 6 over 1. That has a slope of -6. All right? Now, over here, we've got a slope goes down 1, 2, 3, 4 over 1, down 4 over 1. My slope is -4. All right. Now over here at -1, the slope is -1. At 0, there's no slope. The slope is 0. At 1, my slope is 1. At 2, I go over 1, up 4. At 3, it goes over 1, up 6. Okay, and some of you are thinking, what is Mr. Myers doing? And if you are thinking that, then watch the video again. So if you look, and this is for the line y equals x squared. Okay, so you might notice, when x is 1, the slope is 1. When x is 2, the slope is 4. When x is 3, the slope is 6. And if you think about that for a minute, then you're going to say to yourself, hey, when I've got the equation y equals x squared, this x value is getting multiplied by 2, right? 2 times 2 is 4, 2 times 3 is 6. So the slope is going to be 2x. So if I had a point somewhere up here, and if x is 4, then the y value would be what? 4 squared is 16, right? And guess what that slope would be? 4 times 2, which that slope would be 8. Okay, so so my derivative function is 2x for the equation y equals x squared. Okay, so you might see it as dy dx, or you might see it as f prime equals x, f prime of x equals 2x. You're going to see written both ways in the textbook. Now, something that you need to know is we could do this with y equals x cubed, y equals x fourth, and so on. And if we did this experiment, we would end up noticing a pattern. And the pattern that we eventually see is that whatever the power we have here, y equals x to the n power, when we're finding the derivative, the power comes to the front, and this power decreases by 1. So let's look at the previous example where we had y equals x squared. If I wanted to find the derivative, maybe we call that y prime. If I wanted to find the derivative, if the power comes to the front, we end up with 2. And if this power decreases by 1, we end up with x. So the derivative of y equals x squared is 2x. So if my equation is y equals x cubed, then how do I figure out the derivative of that? Okay, if this power comes to the front, we end up with 3x. If this power decreases by 1, we end up with squared. So the derivative gives me the slope for this equation whenever I plug in a value for x. Okay, so let's look at the examples in the book. So, let's look at this example here. So if y equals x to the 8th, what did they do? They brought this power over to the front, and then so instead of 8 being there, 8 is now the in front of the x, and if we decrease this by 1, we end up with a power of 7. Now, if I have f of x equals 1 over x cubed, remember that if I've got 1 over x cubed, I could rewrite this as y equals x to the negative 3 power and bring it to the numerator. You learned this in Algebra 2. Okay, so if this power comes to the front, then my coefficient here, this becomes negative 3, and then the power decreases by 1. So if negative 3 is decreased by 1, the power becomes x to the negative 4. Okay, and this is what you need to know in order to do today's assignment. Now let's look at example 5. Okay, so if I've got y equals 1 over x squared, okay, so I could say y equals x to the negative 2. Okay, find the derivative. Okay, so the power comes to the front, so I end up with the negative 2 right here, and then this decreases by 1, we've got negative 3. Okay, so my derivative is negative 2 times x to the negative 3, and if I wanted to write this, with a power that's positive, I would write it as 2 over x cubed. Now, part B, find and interpret when x is equal to 1. So basically, we want to find the derivative when x is equal to 1. I'm going to plug in 1 in place of x. What is 1 cubed? Well, 1 times 1 times 1 is 1, right? So negative 2 times 1, my slope is going to be negative 2. Okay? So use these examples to help you with tonight's assignment. Tonight's assignment is exercise 20C, numbers 1 through 4 on page 571. This is not going to take you very much time at all.